Okay, time for a little bit of new stuff so we can actually get through this before exams. Where we left off yesterday was at the beginning of loudness. We've talked about loudness and sound before. We said that loudness is really the amplitude of the wave, how much energy it's carrying. I'm sure you've experienced being somewhere where you aren't able to hear, that the object that's creating the sound isn't giving it enough amplitude. What that means is when it's striking your eardrum, it doesn't have enough energy to move your eardrum. You've probably also been in places where the loudness is too loud, the energy is too big, and it hurts your ear to listen. Okay, the lowest sound that we can hear is known as the threshold intensity. So in your notes, maybe find the loudness page. I'm going to just write here, but you might want to follow. So loudness or intensity is really measured in power, how much power, and remember power is energy or work over time. So how much power over the area. And so when we're talking about your eardrum, the area, that's where the pain occurs at a loud sound, the area is really tiny. And so when the area is really tiny, this intensity gets really big. And that's why you can really damage your eardrum listening to loud sounds. And a number of years ago, they were saying young people were going to have hearing problems because they were listening to their music so loud in your earphones, because you're taking a sound that might be loud enough for a room and you're funneling it into a very tiny area. And so you're creating even more loudness or even more intensity than it would be in the room, and it can really damage your eardrum. Okay. If we think about the range, then the lowest intensity we can hear is called the threshold. Okay, so the threshold intensity. It's the lowest energy, the lowest sound we can hear. And it's actually really tiny. It's 1 times 10 to the negative 12 watts power per meter squared area. Like that's a huge, or excuse me, that's a really, really, really tiny number. All the way up to where it causes pain. Up here, where sometimes this is called the pain threshold, but up here where it's painful, the loudness here is 1 watt per meter squared. To the negative 12, all the way up to 1, this is an incredibly large range. Really too large to work with. And because it's too large to work with, like, because we're talking 12, 3, 6 million, billion, trillion. We're talking trillions here, like in the range, which is too big. So instead we've created a scale. It's known as the decibel scale. Deci is a metric unit. One of the very few places that you'll ever see it used. Deci is 1/10, and a bell is really the unit. But decibel tends to be the best size that we use. Bell is named after Alexander Graham Bell, who did a lot of work here, and on this. And this scale is a logarithmic scale. Now, I don't know that you've done logs in math class yet, but on your calculator, if you pull your calculator out, you will see there's a button log. Okay? And so if we take, like, oh, my calculator would be good if I turned it on. If we do 10 and take the log of 10, you'll find out that it's 1. If I take the log of 100, it's 2. Now in this calculator, I have to punch the number in and then do the log. Most of your calculators, you would use log like sine. You do log and then the number, but in this one, it has to be backward. If I take the log of 1, 2, 3, 4, 5, let's do 1,000,000. So 6 zeros, and I take the log. Oh, look, I get 6. Did you notice? Log of 10, 1 0. I get 1. Log of 100, 2 zeros, I get 2. Log of a million with 6 zeros, I think that's 6, I get 6. So what the log scale does is it reduces this big, huge range down into something that's more manageable, between 0 and 12 really here. Okay, so we have an equation, and it's on your notes, and it's beta, which is a Greek letter, the second letter in the Greek alphabet, and it stands for the intensity level in decibels. And so its beta is equal to 10 log I over IO. And the I and the IO are in brackets, and they're inside the log function. The IO is your threshold intensity. Your IO is always, always, always 1 times 10 to the negative 12 watts per meter squared. Your I is however loud the sound is you're hearing right now. And so let's say there's an example there that says, what is the intensity level of a noise whose sound level is 1 times 10 to the negative 10? So the I is 1 times 10 to the negative 10 watts per meter squared. So we want to find out what's the intensity level, what's beta. So 10 log, and on top is 1 times 10 to the negative 10, the sound that you're presently hearing. On the bottom is 1 times 10 to the negative 12, the threshold. And so you do the math. So the first thing you do is divide these two. So 1 EE or EXP to the negative 10 divided by 1 EE or EXP to the negative 12, and you should get 100. So it becomes beta is equal to 10 log of 100. So now take the log of 100, and you get 2. So beta equals 10 times 2. So the intensity level is 20 decibels. Okay? And the units are weird. The watts per meter squared cancel out here. Really, the decibel is probably on the 10. I've Googled it to see how come the decibels just appear, but it seems like it must be on the constant in front, the 10. Okay? Now, let's maybe do one. Okay, before we go backward, if you go to your notes, then you'll see I gave you a whole list of intensity levels. So leaves rustling would be 10 decibels, but an indoor rock concert would be 120 decibels, and the threshold of pain would be 120 decibels. A jet plane, if you're within 30 meters, 140. And that's why if you've ever flown, you'd see all those guys with those ear things on protecting their ears. Okay, so it just shows you that instead of going to like up to 1 trillion with our sounds, using the log scale, we get much prettier numbers ranging from 0 up to like 140 or so. At this point, you're probably ruptured your eardrum, by the way. All right, what if we were to go backward? What if I were to say the decibel reading was, let's say, 6 decibels? And I want to know, so what's the intensity of the sound you're hearing? So it would be beta is equal to 10 log I over IO. And this time you're looking for I. So the first thing you would do would be divide by 10 and get log I over IO. But now remember, the I and the IO are inside the log. So you got to get rid of the log before you can get rid of the IO. So if we were to fill our numbers in here, it would be 6 decibels divided by 10. And like I said earlier, I think the 10 is what has the decibels on it, even though I couldn't find anywhere that had that writing. So you end up having log I of IO is equal to 0.6. So now you need to do, just like you would do sine to the negative 1, you would do like second function or shift on your calculator, log to the, okay? And so above the button on your log calculator, it probably is an e to the x, and that really is like log to the negative 1. So if I type a 0.6 in here, because my calculator is backward, then I go second function log, and I get what that is.